Hello everyone, I'm Putri Nurdiana and I will tell you guys why tomatoes are chosen in this video. For your information, tomatoes are a major food source and contribute significantly to human nutrition worldwide. In vitro regeneration and propagation are techniques used to improve the quality of tomatoes. Based on the article, scientists have successfully used tomatoes, a type of dicotyledonous plant in the Solanaceae family, for genetic modification, mass production, and disease resistance. In vitro propagation has been successful in using almost any part of the plant as an explant, including yellow tomatoes grown in Europe and Asia, mainly in northern Iraq and Turkey. This study looks into the effect of PGRs and explant on the in vitro regeneration of yellow tomatoes, emphasizing the value of plant-based method for human survival.
Hi, my name is Shazwani and I will explain about the methodology of this experiment. The first step is plant material and germination. This experiment used seed of a specific tomato variety sources from northern Iraq, and germination was carried out under controlled condition in a laboratory setting. Next is a preparation of explant, where glassware, equipment, and seed are being sterilized. All materials were initially cleaned with detergent and water, followed by packing metal and glassware in aluminum foil. Then, autoclaving was done at 121 Celsius and 1.5 atmosphere pressure with 25 minutes for media and 1 hour for metal and glassware. For seed sterilization, commercial sodium hypochlorite was diluted to 5% and applied to seed for 20 minutes, then were rinsed with dry double distilled water and incubated in MS and white media to minimize the contamination. In grow media culture, MS medium, sucrose, agar, and various plant growth regulator were used for plant regeneration, and different explant from germinate seedling were employed. In seedling culture, seed were rinsed with dry water, and 5 seed were cultured per petri dish containing PGR-free MS medium with sucrose and agar, and then culture were maintained in a growth chamber with control factor to ensure uniform growth and development before harvesting explant for further experimentation. Finally is in vitro culture condition, which taking explant from germinate shoot. Various explant were excised from 17-day-old seedling and cultured in MS medium supplemented with PGRs. After 3 to 4 weeks, adventitious shoot were developed and transferred to different media for root proliferation. Lastly is data collection of analysis, where the calculation of yield percentage. The yield percentage was calculated by comparing the total number of explant that produced shoot, calyx, and roots to the total number of explant culture. Experiments were repeated in triplicate to ensure the reliability.
Alright, now I will tell you guys the result from this article. The study considered how different PGR concentration and combination as well as different explant affected the adventitious shoot and root regeneration of yellow tomato plants. Following shoot and root regeneration from various explant, plantlets were transferred into pot containing 1/4 sand and 2/4 soil and covered with polyethylene to maintain high moisture levels during adaptation to different field conditions. After 2 to 3 weeks, 60% of the plants were still alive and growing in natural conditions. So from table 1, it shows first, the hypocotyl explant promote callus formation. Second, kinetin promote callus formation in hypocotyl and leaf explant. Third, a low concentration of BAP and NAA promote shoot formation in node explant. Fourth, high cytokinin concentration with low auxin or auxin alone promote shoot formation, and high kinetin concentration promote shoot formation in node explant. Table 2 here was an analyzed data from table 1. Shoot tip and node explant show a good result. And from table 3, on shoot tip and node explant, MS medium supplemented with higher cytokinin and lower auxin concentration resulted in 75 to 100% shoot growth. However, all of the incubated explants show sign of root formation, except the hypocotyl, where it depends on the PGR use, and shoot formation also didn't show up. The development of shoot is a complex process involving potential genes related to hormone biosynthesis, transport, signal transduction, and hormonal interaction. In vitro plant regeneration is regulated by the balance between endogenously synthesized compound and exogenously growth regulators. And table 4 shows first, PGR combination at raw 4 found to be 100% more effective than other auxin combination and standalone therapies. Second, 100% successful shoot regeneration are from nodal segment transplant. And last, 62.5% of adventitious shoot regenerate nodal segments roots produced by 1 mg per liter indole butyric acid plus 2 mg per liter naphthalene acetic acid. And last but not least, in micropropagation, adventitious root induction is a necessary and complicated process that is influenced by the type and concentration of auxin in the first degree. And cytokinin inhibit rooting and have been shown to interfere with the adaptation process.
As the conclusion, adaptation of in vitro regenerate plants is essential since it gets them ready for cultivation and for long-term commercialization. In comparison to natural growth periods, this technique speed up plant development and increase overall production.